Hello everyone, welcome back to Code Studio, and in this video we would be discussing about a new question, sum of round numbers. So what is this question? Recently Codeforces has hosted a new variety of contest known as Div.4, which is pretty cool for beginners. This is a good initiative taken by Codeforces so that beginners can participate in a short contest and can also get to know how the contest experience is without actually damaging their rating. They would also not lose confidence if the questions are pretty tough and not able to solve by them. Div.4 is really a good thing that I have seen in recent times by Codeforces. So I would also recommend every beginner to participate in Div.4 and boost up their confidence to a new level. Even if you are still practicing your language, just move on to Div.4 and try it out, because you don't need heavy data structures and algorithms to solve the initial like 3 questions. So the question we are discussing in this video would be the first question, that is sum of round numbers. What is this question exactly? You can find the link of the question right in the description below, or just you can go pause this video and read the question right on the screen in front of you. So I hope you have read the question and understood it properly, but as a general note, I'll just give you a brief glimpse of what the question is using an example. Here in the example, you are given a list of numbers and you have to print the minimum add-ins required to minimum add-ins that are round numbers. So what are minimum add-ins? So if you take the first number 5009, it can be denoted as a sum of two rounded numbers 5009. The number 9876 can also be represented as a sum of 900 plus 800 plus 70 plus 6. If you have done basic math in your elementary or primary schools, this would be a cakewalk for you, because they've just asked to print out the place values of the numbers. Right, I'll just show you what are the place values and how to go and tackle this question. I know many of you know what are place values and stuff. So let me explain the actual procedural route by using the first example, that is 5009. So the first number 5009, I've been visualizing 5009 to be in a contiguous memory, that is an array, actually a zero based indexing array, in which is in front of you, is what I'm imagining 5009 to be in as. And the length of the array or the length of the number is depicted on the right hand top corner as len equal to 4. Since we are discussing the procedure using an contiguous array, so you have to convert the given integer number into an array. So 5009 is depicted as 5000 plus 9 without the plus sign, of course. So 5009 can also be written in place value terms as 5 times 1000 plus 0 times 100 plus 0 times 10 plus 9 times 1, out of which the two terms in the middle, 0 times 100 and 0 times 10, are insignificant. They are of no use because they are being multiplied by 0. So we are not showing any answer also on the output screen. So the 1000, 100, 10 and 1 corresponds to the thousands place, hundreds place, tens place and ones place respectively, which are shown just above the numbers. So you can also depict them in the scientific notation as 10 cube, 10 square, 10 power 1 and 10 power 0. This is pretty simple. If the number is not 0, then we have to print the addend like 5, like the digit, times its place value, right? So that is pretty simple by adding an if conditional that the given digit is not a 0. How to find the place value for a particular digit? You can find a pretty good relationship between the length of the array and the index of the each digit. So this is as follows. Each relationship is splitted and shown above on the array, and the variable thing is the index 0, 1, 2, 3. Right in the middle, 4 minus 0, 4 minus 1, 4 minus 2 and 4 minus 3, and the whole thing is subtracted by 1, and the length is also variable, but for this particular array it's constant. So the formula that actually gives us the place value holder for a given digit is 10 power length minus I minus 1, right? Let's just summarize what we have discussed into steps so that we can go on code in our text editors without any hassle. So the step number 1 would be finding the length of the given number, the number of digits in the given number. This can be found using a while loop by running across the number and dividing it by 10 just as to remove the last digit of the number, right? and we have to transform the given number into an array and use the formula, that is 10 power len minus I minus 1, that is the placeholder value, to get the place value of each digit in the array. If the digit is not 0, we tend to print the place value of each digit. The place value is nothing but the digit times the placeholder value, that is 10 power len minus I minus 1. So if you want, you can take a screenshot of this photo and try coding on your own in each step so that you don't go wrong anywhere. Now let's just go on to your code editors and start coding. We are up and running on our code editor and have saved a file 𝕲𝑚𝑜𝑓_roundnumbers.cpp. Let me start with including the header file. Let me open the question to know what's the input type. Every time you solve a question, you should get an idea of how the input is being made. Like, are they giving any number of test cases to be inputted, or is it a single test case or stuff like that? As you have seen the question and examples, you know there are test cases, but as a standard convention or a standard procedure, you just have to check every time that whether there are any special requirements on the numbers. Like, you know, sometimes there are conditions on the input, like it can be more than number of bytes that can be hold it in an int variable, so then you have to use a long int variable. So just make sure you check every time, right? So here it's given that input contains the first line to be a t that contains the number of test cases to be inputted. Then for each test case, an integer n is to be inputted, and the integer n is only 10 power 4, which can be holded by the int variable, and the t 10 power 4 can also be holded by the int variable. So first let me declare a t variable and input the t variable. So I have to run a loop on all test cases. So this is a very good convention to write the looping of test cases, because when t minus minus reaches 0, automatically the while loop breaks, right? So you don't need to write like for I equal to 1, I less than t, I plus plus and stuff like that, because it becomes a pretty long for declaration, right? So while is simple. I'll declare an int n variable and input it as well. After inputting, as we have seen, the step number 1 would be to find the length of the array. Find the length of the number, right? So we tend to not disturb the initial number, so I'll declare another variable temp that stores the number n. We'll do some operations on the temp variable, not on n, because if we modify the n variable, then if we wish to use the n variable again, it would be modified and it would be of no use. So I'm declaring a temp variable, a working variable, so that I can do any stuff I like on it. So let me loop it. Let me write that condition later. So what I will do is I'll just divide it by 10 every time it runs a loop. So what is dividing by 10 means? So this just removes the last digit. So if temp is not equal to 0, that means all digits are run and then loops breaks. So if all digits are done, we can count the number of digits in the array, and we'll assign to it a variable. So len plus plus would take care of incrementing the length, how many times this loop runs, right? So let me declare the length and initialize it to 0. The temp is modified. Let me bring back my temp to n again so that I can work anything again on n. So step number 1 is done. So I'll do step number 2 by inputting into an array. How do I input on an array? So temp by 10 removes the last digit of the number. So how to get the last digit of the number? So temp percentile 10, that's actually temp mod 10, gives you the last digit of that number. I'll run a for loop in this case, and the iterator would be I, and let me declare it later. First let me know what is happening inside, then I can declare if it's an incrementing loop or a decrementing loop. So let me divide it. So I'll store the array of I indexing to be the temp percentile 10, that would be the last digit. So the last digit would be stored in the last array, right? So the I starts at len minus 1 because this is an zero based indexing, and I goes upon until it reaches 0. And this is a decrementing loop. We are coming from the end, right? So I minus minus. So we are storing the last digit of the number into array's last digit. That's pretty fine. We are going in the right manner. Since we found out the last digit, we have to remove the last digit also. That is what we have seen earlier. So 10 by 10 removes the last digit. And anything else? I guess nothing. We are inputting it into an array. Step number 3 and 4 would be simultaneous. Again 3. Wait. Okay. So this would be like I'd be running a loop from the start, incrementing the loop int I equal to 0, I less than length, and I would be incrementing the iterator. And what I would be doing is, if the digit is not a 0, so if the digit is not equal to 0, then I would print the answer. So let me also check how the answer is. Oh wait, we have to print how many addends we are printing. So what are the number of addends like? The number of non-zero digits. So let's just add a condition here. In the inputting into array, if array of I not equal to 0, let me increment a counter, and let me also declare a counter and initialize it to 0. So I'll get the counter, right? So initially I have to print out the counter value, and so since we have to print it in the next line, I have to also add an inline character right there, and we have to print 5000 space 9, right? So we have to print a space between them. So cout array of I times power of 10 comma I minus len minus 1. This is what we have seen in the slides. So space here. Wait, we are using a power, but we are not including any related library to it. So I'll include the CMath library that includes the power. So CMath would do the job for us. I think we are done, but wait, after every test case, we have to move to our next line. So where does this for loop ends? Yep, here. So I'll include an endline character here, and this should work pretty well. After adding the counter, it says like I have to also include the array. I have not declared the array. Without declaring the array, I am inputting into an array. That's pretty foolish thing I have done. And one more thing, wait, this formula is wrong, right? So it is len minus I minus 1. So this should work fine. Let me try this on a terminal with the test cases. Okay. This went compiled without any errors. So let me run the test case. So I should include the test case. Let me copy it to my clipboard from the Codeforces website. So I'm printing it. So my answer starts from here. So let me verify 2, 5009, 1, 7, 4. This can be in any order, I suppose. Yeah, if the terms can be printed in any order. So that's fine. 9870 and 6, 1, 10,001, 10. I'm pretty good. So let me submit the code and let's wait for the verdict. So I'm submitting the code. I submitted this already. So yeah, accepted. Working fine. So since we have seen that our code went perfectly fine, so this is how you go on approaching a problem given on any coding platform for that matter. The first and foremost thing you have to do is properly analyze the data, properly analyze the question, what is given for you, what is that you have to do, and what is that you have to output, and figure out the correct data structure or any basic logic implementation method, a math method involved behind this, and then code for it in your language of choice. I'll see you back in another interesting Codeforces editorial. If you wish that I have to do an editorial on any particular question, just link that question in the description below and I'll try to do it for you. Until then, thank you. Stay home, stay safe. Signing off, Sai Ankit.